All right, if you've ever built anything with AI, you know the feeling, that struggle to get a large language model to give you exactly what you want every single time. Well, today we're diving into a technology that promises to shift us away from just talking to models to actually programming them. It's called LMQL, and believe me, it's a fundamental change in how we can control AI. You've been there, haven't you? You carefully craft a prompt asking for clean JSON, and what do you get back? A friendly, chatty paragraph. Or you build a complex multi-step agent, and then you see your API bill and your jaw just hits the floor. This friction, this gap between what we want and what we get, that's the core problem we're going to tackle today. And here's how we're going to break it all down. First, we'll get to the heart of the prompting problem itself. Then, we'll introduce this whole new way of thinking, language model programming. After that, we'll look under the hood at the magic of constraints, see how that leads to some major savings, and finally, figure out exactly where LMQL fits into your toolkit. To really appreciate just how big a deal this is, we first have to agree on the problem. So let's start with the way things are usually done, with traditional prompting, and really pinpoint why it's holding us back. With traditional prompting, you basically run into four major headaches. First, your prompts get super complex and brittle. They just break if you look at them wrong. Second, and this one is huge, you can't actually guarantee the output format. You ask for JSON, but really you're just crossing your fingers and hoping for the best. Third, trying to build anything with multiple steps becomes a tangled mess of code. And finally, the whole process is just inefficient, burning through API calls, which costs a ton of money and makes everything super slow. So, if prompting is the problem, what's the solution? Well, the researchers behind LMQL are proposing a pretty radical shift in our thinking. It's a move away from prompt engineering and towards something they call language model programming. Language model programming, or LMP for short, is the big idea here. It basically says, let's stop treating the LLM like some magical, mysterious black box that we just talked to. Instead, let's treat our interaction with it like a formal program, where we can use scripts, we can use logic, and, this is the most important part, we can use explicit rules to guide exactly what it does. And this is where LMQL finally enters the picture. It was developed at the SRI lab at ETH Zurich, and it's not just some academic philosophy. It's the first real, concrete tool that makes this idea of language model programming a reality. You can think of it, quite literally, as a programming language for language models. This is probably the single best analogy for understanding what LMQL is all about. You know how SQL, the structured query language, gave us a reliable, structured way to pull specific data out of a messy database? Well, LMQL does the exact same thing, but for text. It gives us a reliable, structured way to get specific text out of a language model. It's a total game changer. So at its core, LMQL is this cool mix of natural language and actual programming code. You still write your prompt like you normally would, but now you can add placeholders like answer for the model to fill in. You can inject data straight from your Python code. You can even use if statements to change the prompt on the fly. But the real powerhouse here is that where clause. That's where you define the rules the model absolutely must follow. Yeah, that where clause is the key to everything. It's what lets LMQL make actual guarantees, something that traditional prompting could never, ever do. So how does this magic of constraints actually work? Let's pull back the curtain. The difference in the approach here is just night and day. The old way is what I call generate, then validate. You let the model generate its whole response, then you check if it's what you wanted. If it's not, you just throw it away and try again. It's so wasteful. LMQL, on the other hand, uses eager enforcement. It validates the output as it's being generated, token by token, ensuring the final result is perfect from the very first word. The secret sauce that makes this possible is a technique called logit masking. Now, here's a simple way to think about it. Imagine at every single step before the model picks its next word. The LMQL runtime looks at every possible word in its vocabulary. It then masks or forbids any word that would eventually lead to an invalid output. It's like it's putting guardrails on the model, forcing it down a path that is guaranteed to be correct. And the level of control this gives you is just incredible. You can force the model to stop at a specific word. You can guarantee the output is a number. You can even restrict its answer to a predefined list, like only yes or no. You can control the length or even make sure it follows a super complex pattern. You are no longer just hoping for the best. You're in control. So getting guaranteed output is awesome, but that's really only half the story. All of this cool technical wizardry translates directly into a massive tangible benefit for any business. Huge cost savings. Just look at this number. This is the payoff. By completely eliminating all that waste from failed attempts, the research verifies a cost reduction of between 26 and 85%. For any company that's using AI at scale, that is a staggering amount of money. This isn't just a quality of life improvement for developers, it's a strategic financial advantage. So how does it do it? Well, there are 3 key efficiencies at play. First, it short-circuits bad outputs the second they start, saving a ton of tokens. Second, by guiding the model, it makes complex generation algorithms run way faster. And third, it intelligently caches results, so it never has to compute the same thing twice. It's just smarter. Okay, so a question that's probably on your mind right now is, this sounds amazing, but I already use tools like LangChain. Is this supposed to replace that? It's a great question. Let's clarify exactly where LMQL fits into the modern AI stack. First, let's just be super clear on what those other tools are. Frameworks like LangChain and Llama Index are orchestrators. Their main job is to manage the high-level workflow, chaining together different steps, an LLM call here, a database lookup there, to build a complete application. The distinction is actually really simple. Think of LangChain as the general contractor on your AI project. It manages the high-level plan. LMQL is the specialized, high-precision tool you bring in for a really critical task, like ensuring a perfect cut every time. They aren't competitors, they're partners. You use LMQL inside of LangChain to make each individual step way more reliable and efficient. And here's another huge advantage: portability. Your LMQL script is totally separate from the model it's running on. This means you can write your logic one time and then run it against OpenAI or a local model you're hosting yourself, or pretty much anything in between. This is how you avoid getting locked into one vendor and gain complete control over your costs and your data privacy. And to top it all off, it's completely open source under the Apache 2.0 license. Now, this is a really big deal because it means any developer or any company can use it in their commercial products for free with no legal headaches. It's built for wide-scale adoption. Ultimately, what LMQL does is it brings the reliability and predictability of engineering to the beautiful, creative chaos of natural language. It gives us the tools we need to build truly robust, production-grade applications on top of these incredibly powerful models. Which brings us to a final, really provocative thought. As we move from just crafting prompts to writing structured programs that control models, are we witnessing the end of prompt engineering as we know it, and the true beginning of a new era of language model programming? It really feels like a fundamental shift in how we interact with artificial intelligence.